Well, I make it 2 minutes past the hour, so I suggest we make a start. So welcome everyone. We've got more people arriving all the time, but they can join in as and when they arrive. Welcome to IWOCL and SYCLcon 2021. I'm Simon McIntosh-Smith. I'm from the University of Bristol. I'm chairing the conference. This, would you believe, is the ninth time we've run this conference. It feels like just yesterday when we ran the first one, and already we've been going for 8 years. It's pretty incredible. And this afternoon or this morning, depending on where you are, I'm delighted to welcome some panelists to talk about OpenCL. We have a live SYCL panel tomorrow, so if you're also interested in SYCL, make sure you come back tomorrow. Just before we start the panel, I'm going to do something we traditionally do at the start of IWOCL, which is I have this chart I show each year, where I use Google Scholar. I do something really, really simple in Google Scholar, and I type in the names of different parallel programming languages into Google Scholar, and I get them searched by year to see how many times all of the different languages are mentioned in each year. And I refresh the data every year. So I'm not using old data and just adding on numbers for this year. I refresh the whole thing just in case the algorithms have changed in how things are found. And the trends are really interesting. And in fact, there's something that's standing out this year more than ever before is most of the languages have been slowly sort of flattening or trending down, mostly as they become kind of assumed. They're almost, everyone is just using, if you're in high performance computing, you use MPI, you use OpenMP. So they're not really being mentioned quite so much anymore. And pretty much all of the languages have been going through the same thing, apart from the one obvious outlier, which is CUDA, which had also flattened off. But in about 2016, it started to climb again. And it's really obvious this year that's carrying on. So I actually dug into that a little bit this year to find out what's behind this. And I took a guess, and it turns out to be right. And what's been going on is, if you add the keyword AI into the search in Google Scholar, and how many of these papers mention CUDA and AI, up until about 2015, 2016, it was about 10% of all papers mentioned both AI and CUDA. 90% didn't mention AI. Since 2016, that number has grown from about 10% of all papers to about 26% of all papers. So it's a big AI bump, basically, as AI has really taken off in the last 4 or 5 years. And as Nvidia has really sort of capitalized on that, we're seeing a huge sort of bump again for CUDA with AI. So I thought that was very interesting. So we're going to keep this going. We'll see what happens with this in the future, but it's interesting to watch some trends going on there. And with that, I'm going to come to our panel. We've got a really great group of people here today, and they represent the OpenCL standards group itself, as well as users. So we've got people here who've got all sorts of interesting insight and opinions and experiences with OpenCL. And they're all here to answer questions today. So what we'd like as people arrive to ask questions, rather than posting into the chat, into the Zoom chat, we've got a QA box. So we've got a Zoom webinar QA box. If you've got questions that you'd like to pose to the panel, anything to do with OpenCL, please start to populate them in that QA box. You can put them in any time from now onwards, and I'll keep my eye on those, and we'll start to pose those questions to the panel on your behalf. So do take a look at that. So with that, I'm going to stop sharing my screen so we can actually see our panel, and then I will ask them to introduce themselves. So there's stop sharing. You can hopefully see all of us. So we're real people. So if we go around on the screen, I'll go around on my screen in a clockwise fashion, so it might be different for all of you, but at least I'll keep track and I won't miss anyone. And I'm going to start off with Paul Miller. Paul, if you can just introduce yourself, please.
Yes, hi, I work at Boris Effects. We make visual effects software for the post-production movie industry. I'm responsible for 2 products, Silhouette, which is an Academy Award and Emmy-winning rotoscoping paint compositing system, and also Optics, which is a photo editing package for Photoshop. And most of the image processing functionality in these products are implemented using OpenCL.
Thank you, Paul. Next, Kevin.
Sorry for that, unmute button. So I'm a GPU compute software architect at ARM, and one of the things that entails is looking after our OpenCL implementation for Mali GPUs.
Thank you, Kevin. And next is Jesse from Microsoft.
Hi, I'm on the DirectX team at Microsoft. For this particular panel, I'm here representing the OpenCL on 12 implementation that we just released last year, which is OpenCL currently 1.2, implemented on top of D312 as a layered implementation.
Great, thank you. And then Alastair from Codeplay.
Hi, so I oversee the development of products at Codeplay. So it includes an implementation of OpenCL, but also an implementation of SYCL on top of OpenCL. In terms of standards, my personal involvement is mostly in OpenCL.
Thank you, Alastair. And then Neil from Nvidia.
Yep. Hey, everyone. I'm Neil. I work on developer ecosystems at Nvidia. I'm president of the Khronos group and chair of OpenCL.
Thanks, Neil. And then last but not least, Ben from Intel.
Hi, everybody. I'm Ben Ashbourgh. I'm a software architect at Intel. I focus on GPU compute. I'm one of the OpenCL spec editors, and I also co-authored a book late last year about SYCL in the DPC++ compiler.
Fantastic. Well, thank you everyone on the panel, and thank you for giving up your time today. So we'll open up for questions from the audience. So please do start to type questions into the Q&A. Rather than the chat, we'll be able to see them in the Q&A a bit more easily. As you're starting to type those in, we've got a few that have been posed already. And I'm actually going to start off with a slightly more general one, because there's been quite an exciting development with a new version of OpenCL 3 that's come out recently. And in fact, in general, OpenCL 3 has been quite a big thing over the last year or so. And so quite a few people have asked what the sort of biggest changes are with OpenCL 3, what have been the big advances, and more specifically then, what are the very latest things in the new release that's just come out. So I don't know who would like to take that one.
I guess I can start. The biggest thing that's new in OpenCL 3 is we added a lot more optionality to give more implementation flexibility. What we found was that OpenCL 2 had a lot of good features, but not all of them made sense for all of the target markets. And as a result, it was essentially a big roadblock for implementers. And we didn't see a lot of OpenCL 2.0 implementations or OpenCL 2.0 adoption. Since making things more optional, we've seen a lot more uptick in OpenCL 3. That doesn't mean that the optional features aren't being implemented. It just means that there's a different mix of features for different markets. So a lot more implementations, which is a very good thing. In the latest release, we've been focusing mostly on OpenCL extensions. I'm not going to list them all right now because I'll probably forget them. But that's been our view for how to add new features. Is we go out with extensions first. That would give some proof that the features that we're adding are valuable and are implementable. Once they've been implemented, then we'd roll them into the next version of the standard.
I guess I can chime in that from my point of view, OpenCL 3 definitely seems like a huge step forward. There were definitely a lot of roadblocks that we looked at when we were talking about which version of OpenCL should we try to implement. And there's a lot of really cool features in the 2.0 and 2.x area, but there were definitely some that would be very challenging for us to implement. So I'm looking forward to being able to actually support some of them without having to necessarily go for everything.
Thank you. There's a sort of a closely related follow-on question, which partly addresses the first question, which has just come on, which is also to come to NVIDIA. So Neil, I know this has been quite a big deal for NVIDIA, hasn't it, with OpenCL 3?
Yeah, it's kind of enabling for us. I mean, contrary to popular belief, NVIDIA is very supportive of OpenCL. But we had the same problem with 2.x that Jesse was just mentioning, and the working group as a whole was talking about last year, that it was some awesome functionality, but it was all lumped together in one big monolithic lump, and so it became too unwieldy to implement. But 3.0, it breaks that bottleneck, and so we can begin to establish the baseline, but then more importantly, move forward with new functionality. And hopefully people saw that as of a couple of weeks ago, OpenCL 3 is now fully conformant on NVIDIA. They are shipping those drivers, and it's both source and binary compatible with our 1.2 drivers. We're already beginning to ship new functionality, things like clone kernel. But more importantly, looking forward, there's going to be some really cool functionality like Vulkan interop. It's a set of extensions that the working group's been working on together, and we're getting close to being able to release the spec and release the drivers with that functionality. So it's going to be good to see the wavefront of functionality that's widely available move forward.
Great, thank you. I'm going to come across to Paul actually. Paul, just before we started the panel, you were talking about you've had to kind of stick to OpenCL 1.2 for various reasons. Are there specific things you really wanted that came after 1.2 that OpenCL 3 might make a bit more accessible for you?
Yeah, the biggest one for me, writing visual effects plugins and kernels, has been we're working with red, green, and blue and alpha channels instead of X, Y, Z, and W. So the big one that I've always wanted is just being able to access vectors as RGBA rather than XYZW. I've made so many mistakes with compiling kernels where I'd accidentally put in RGB. So that was always the biggest one, and I've just been waiting for everyone to sort of provide that functionality.
Cool.
Everyone taking notes.
Yeah. Yeah. We've got some more questions coming in. So another question's just come in. What's the current status of OpenCL on mobile devices? That's a good one. Who can comment on OpenCL on mobile or mobile?
I'll take that one. I would say that all major mobile vendors support OpenCL these days and are fairly committed to OpenCL, including ARM. The level of support, the version supported, has tended to be fairly close to the edge on mobile devices, with ARM supporting 2.1 and others 2.x.
Cool. That's a good one from ARM. Anyone comment on any of the other mobile platforms?
I agree with Kevin. It's actually really interesting kind of dynamics because of course, Android doesn't include OpenCL in its platform definition, and therefore you think, well, it's not shipping on Android. But as Kevin points out, pretty much every mobile SoC vendor does ship OpenCL drivers. If you look at the kind of range of AI engines running on mobile, we actually went down the list and say, which ones are using OpenCL? It's to a large extent all of them. All of them are using OpenCL either exclusively or as an option. And it's kind of a hidden vein of OpenCL activity in the mobile space. Even though it's not part of the platform, it's adding enough value that the SoC vendors and the key developers developing video and imaging and increasingly machine learning applications, they are using OpenCL as a backend. It's a very interesting dynamic.
I think there's an important distinction to make here, and that is mobile is not Android only.
Yeah.
Meaning embedded too, Kevin?
Yes.
Yeah, I agree. Yeah, that's the other big growth area that I think is the next round of growth for OpenCL is the embedded space. Computers are becoming all kinds of shapes and sizes, so OpenCL can be there for that.
Yeah. So there's a follow-on question that says, it's just me. Speaking of OpenCL on mobile, Qualcomm released an extension for OpenCL for machine learning operations. Are there any plans to standardize such a machine learning API set in OpenCL from Khronos? Or I guess that's in general, that's the sort of machine learning API, because Khronos comes up with loads of APIs for all sorts of different things, doesn't it? It's amazing. Is there a machine learning initiative that might be part of OpenCL or separate?
There are multiple initiatives actually in that space, and while there is no initiative to deliver something similar to what Qualcomm has shipped so far, there are discussions ongoing around several of the building blocks that would be necessary to do that.
Yeah, in general, I think Khronos is trying to reach out into the machine learning developer community, people creating frameworks and compilers increasingly, because we do have multiple APIs that can be used for machine learning. OpenCL will obviously is one, SYCL obviously is the obvious other one, but also Vulkan, also OpenVX. So it's not a single API for machine learning. It's machine learning is seeping its way into pretty much all of the compute APIs that we publish.
Very good.
Quite a few of the extensions we're working on are for machine learning use cases, even if we don't say machine learning in the title. Like things like the command buffer extension is in progress. We definitely have machine learning use cases in mind when we're writing that.
Yes, and that's what I alluded to when I said I was speaking of building blocks, really. So we don't have a full-on ML primitives extension in the works.
Go ahead, Ben.
In Neil's slides too, he had a list of extensions on the extension roadmap. And on those slides, there was a link to GitHub where we were actually looking for feedback from the developer community on which extensions to prioritize next. So maybe my call to action for the attendees is, if there is an extension, including the Qualcomm extension that you all would find interesting, please do go to that GitHub issue and provide your feedback, and we'll definitely feed that into our extension roadmap.
It's a really good point, Ben. Thank you.
Yeah, and it's interesting. We've been trying to keep close tabs on what the frameworks actually need. Do we start building some quite complex ML primitives like direct ML does, and that does get used, and the Qualcomm extension is quite a lot of machinery to deliver inferencing performance. Or do we keep it simple and atomic and let the compilers do the work? And that's an ongoing trend that we and probably it's going to be a mix of both in the end, I suspect.
Yeah. Before we go on to the next question, Tim, this might be a good time to pop up the first poll for the audience. Now we've got over 80 people here. So we've got 3 questions we'd like to pose to you all. So it's not just you asking the panel questions, we want to ask you questions as well. So the first one of those should come up any moment. There we go. So the first one's about, are you using OpenCL? And if so, what version? So it's going to be very interesting for us to know. So if you click on that, please, and click submit, and then we'll get to see the results in a moment. And then while you're doing that, with OpenCL 3, now it makes almost everything optional. You have these feature sets. Now, in the past, if someone said, I'm OpenCL 1.2, we knew what that meant. If they said, I'm OpenCL 2, we knew what that meant. How is there a good way that we can keep track of, if everyone says OpenCL 3, what subsets of things are they actually supporting? Is there a way we can do that? Not sure.
I think we're going to end up, it's an excellent point, Sam. You just maybe think, Vulkan has the same issue, right? Because Vulkan 1.2 is Vulkan 1.2, but there's a whole bunch of different extensions. And that ecosystem, actually, it wasn't a Khronos thing. It was an ecosystem thing. They ended up with the gpuinfo.org database, that goes and scouts out what people have on the various machines and posts a database of up-to-date real-world information. Maybe we need something like that as we move forward with OpenCL 3.
Yeah, well, it'd be interesting to hear what the audience, if they have ideas for this as well. Excellent. I'm just scanning down what questions have come through. There's a related question from Raul. If he understands correctly, Nvidia is going to support OpenCL 3 since it allows optional features, and he assumes it's easier to support specific features, but not all. I think that's basically what you said, wasn't it, Neil? Yeah,
but it's worth restating because we're excited. Nvidia's excited about shipping 3.0, and it's not we're going to support it. We've shipped it. It's in the production drivers. You download the latest drivers from Nvidia. It includes OpenCL 3.0, and it does have some additional, already it has some additional functionality over and above 1.2. But yes, the question in the chat there, it was because 2.x was so monolithic. it would have taken a lot of effort to implement functionality that none of our customers were asking for. It just didn't make sense. The calculus didn't make sense. And so 3.0 has broken that bottleneck. So now we can focus on the functionality that our customers need. We're going to ship that, and we're obviously going to be working in the working group to find the commonality between all of our customers and put that new functionality into core as we move forward. And as Ben says, that's why we need the feedback from the developers. Please tell us what's you're using, what's useful, what's not, so we can do that prioritization correctly.
Thank you. Tim, I think we very briefly saw the poll results and they disappeared before we had a chance to look at them. Is it possible to bring them back? There we go. All wonderful. So I guess not surprisingly, OpenCL 1.2 is still the most popular. A little bit of OpenCL 1. There you go. I'm surprised you still got some older ones. I guess that might be some older FPGAs, but quite a spread across the OpenCL 2s, even a little bit of OpenCL 3. And maybe 1 in 5 people here not using OpenCL yet. So that's great to have all of you here as well. And it's a good way to find out a bit more. That's really good. Hopefully we get to capture this, I think. And we'll try and share this as part of the sort of output of the panel and the workshop in general. Thanks, Tim. There's one more question which sort of follows on from what we've been discussing, and then we'll switch to a different topic. But Andre asks, while making some features in OpenCL optional would simplify creating compatible implementations, are you not worried it will make it harder to use OpenCL as a framework and fragment the ecosystem if different vendors choose to implement wildly different sets of these optional features? So what is there a risk of fragmentation here? And Neil, I think you were talking about Vulcans had the same sorts of issues. And how did they solve this, or how are they trying to solve this?
Yeah, so Vulcan does have this issue. They don't have feature sets yet or profiles, but they're having quite in-depth discussions right now. Do they want to have profiles? I think they will end up with profiles. Profiles in some description probably is a helpful mechanism to we've enabled this freedom with 3.0, but the questioner is quite right. The danger is fragmentation, and profiles where we say, okay, if you're on desktop, this is the minimum bar, and for mobile it may be different, and for embedded it may be different. I think it is probably going to be a discussion that we need to have at OpenCL as well.
Cool. Does anyone else on the panel want to comment on that one?
Ben.
Yeah, I think one of the main realizations that we had in the working group is that we were already fragmented. There were some vendors that were implementing 1.2. There were some that were implementing 2.x versions. There were extensions pulling things in and out of different spec versions. So, in a way, I don't think we made the problem worse. And I think in some ways we made it better because everybody is, on OpenCL, or most people are moving to OpenCL 3 now. They have the same, query mechanisms to figure out what optional features are supported. And additionally, we broke that roadblock where, if a vendor wanted to support something from a newer version of OpenCL, now they're able to do so, and they don't have to pull along the rest of the phone company with them.
Cool. I think
Cool.
From a developer point of view, what would be nice, and I think it works for both Vulkan and OpenCL 3, would be to have a convenient place on the website where a developer can go look and see what vendors for which driver version support which of those optional features. Like I've been avoiding even looking at 3 because I know this whole extension system going back from my OpenGL days, you never knew what you were going to get. So what was nice about the profiles is you knew what you were going to get. So it would be great if there was a central location where you could go look and maybe the vendors could keep it updated.
Cool. And is that similar to the GPU info thing you mentioned, Neil, for Vulkan? Is that how?
Yeah, it is. That's exactly it. And again, the interesting thing is it wasn't Khronos, even though it was Sasha Willems that did that. And we can. It's not a huge effort, and maybe we can go and do something similar. I think we'll need to.
Excellent. I'm going to go back to the questions that are coming in now because they're starting to stream in. And we'll ask a SPIR-V question now, because we've not touched that subject yet. Robert asks, shouldn't SPIR-V support be a hard requirement for future OpenCL releases because of its massive impact? Obviously, especially in your talk, Neil, you make it clear how much SPIR-V is kind of underpinning a lot of what's going on in the ecosystem now. So should that be a hard requirement in the future? What's the thinking there?
I would love it. I would love it to be. I think it's a matter, and I hope and believe it will be. And Nvidia does not support SPIR-V in its 3.0 right now. Personally, I think we should. I'm pushing for it.
What can we do to help?
Keep asking.
84 people on the thing. Look, we can all write to Nvidia.
Yes, please all write to Nvidia and ask for SPIR-V. I'm not actually not joking that much. That it's going to be, if the developers ask for it, that's going to be, and they are asking for it. It is enabling. It's a matter of timing now. If we'd mandated it in 3.0, which we did discuss, it would mean Nvidia wouldn't be able to ship 3.0 today. So I think we would be in a worse off place. But it's definitely a goal. I think that many, if not all of us, share that to have pervasive, universally available SPIR-V, just like Vulkan has, because they made that decision from the get-go. We have some history behind us, so we need to make the transition more carefully. But yeah, it's something that we all think is a good idea.
Anyone else on the panel want to comment on that SPIR-V?
I guess I can quickly chime in. I haven't heard much developer feedback for OCL on 12 yet, but so far, basically, the only feedback that I've heard is please support SPIR-V. So I can definitely agree that that sounds like a widely requested feature. And I have been doing some work to try and get OpenCL 3.0 support, and the first big feature that I'm looking at is SPIR-V support.
Very cool.
Cool.
Yeah. Excellent. Let's see. A question from Martin. Are there efforts to improve the tooling across implementations? For example, the OpenCL SDK from GitHub would be very important to allow easier cross-vendor development. It is unfortunately moving quite slowly. Also, what about supporting cross-vendor tracing, profiling, analyzing, etc. tools? So a question about tools. Maybe this is a good one for Alastair. Are you able to sort of comment on the sort of tools ecosystem?
So yesterday there was a tutorial on the new ICD loader layers implementation, which is a very helpful first step to be able to provide things like these in the future. That capability only got added to the ICD loader in the last few months, so there isn't much use of it yet. But hopefully that provides a good area for vendors to be able to collaborate going forward.
What kind of things should that enable?
Things like validation layers are various obvious starting point, but it could also allow tracing and profiling layers. I could also pass over Ben here to talk about his intercept layer.
Well, I was coming to Ben next, yeah, because Ben produced a really cool tool. Do you want to mention?
Yeah, so I do think it's worth talking about the layering ecosystem that we've enabled in the ICD loader. I mean, the example of things that could be added there is really anything that's in Vulkan. Vulkan's had a layering infrastructure ever since day one. In the meantime, though, while that's being built out, we do have an open source tool, the OpenCL intercept layer. You can find it on GitHub. It does support cross-vendor tracing, profiling, a lot of analysis. I do hope that that'll eventually migrate some of the functionality to the ICD loader layers. But for now, I would say check that out if you haven't. We use it every day, so I think it's very useful.
And maybe that's, if it's easy to put the link for that in the chat, Ben, well, so then everyone can check it out. I mean, when I teach to an undergrad class, I point them at that and they find it really useful. So it's a really good tool.
Well, I'll find the link in a minute.
Thank you. Excellent. Anyone else want to comment on tools before we move on? No, thanks for that question. Question from Tom. Any news on including the OpenCL C++ kernel language, part of 2.1 and 2.2 in the 3.0 spec? There seems to be some overlap with what SYCL's offering in terms of productivity. Now, I know, Neil, this is something you talked about quite a lot in your in your State of the Union talk, wasn't it, about what's going on? Do you want to just quickly sort of recap C++ and OpenCL?
Yeah, I can recap it, then other folks can dive in with more details. The important thing with 3.0 is we found that the implementation barrier to implementing the spec, that was a part of the spec that was better served by open source, where we can share the implementation load. And now we're recommending people use the C++ for OpenCL front end, which leverages Clang and LLVM and generates SPIR-V, which loops back to why we need SPIR-V. But it is, I think, the forward direction. We would recommend people using that open source front end. It's just people want to add more detail to that.
And then the second part of the question was about sort of the overlap between C++ in OpenCL and then SYCL. So somebody like to comment on that aspect?
I think it's quite different. Writing kernels, I mean, you're still writing kernels, even though it's in C++, which is obviously different to SYCL, which is much more unified. Ben, do you want to comment?
Yeah, I can too. I think Alastair can comment a bit more also. I mean, there's a lot of similarities and there's a lot of differences too. With the C++ for OpenCL, you're still writing kernels. They're still, typically in separate files compiled through separate compilers. SYCL is very much more of a kind of a unified C++ experience where you write one source file that contains your host code and your device code, and the SYCL compiler has visibility into both of those. So I don't think it's either or. I think it's one or another, and some people are going to feel very comfortable with the the kind of specific kernel method of programming, and other people are going to like the single source SYCL experience.
Also, in terms of
sorry, go ahead, Alastair.
Key difference in terms of implementation is, like Neil said, is you can build things like C++ for OpenCL on top of SPIR-V. So vendors don't even necessarily need to support it themselves. We just need to support SPIR-V. So it's a nice carrot to try and get more vendors interested in SPIR-V as well. Whereas SYCL is a completely different programming model, so it is a full implementation of this different thing.
Great, thank you. Anything else anyone want to add, or go to
yes.
Go ahead, Kevin.
Adding to that, actually, one key aspect of C++ for OpenCL is that it offers backwards compatibility with OpenCLC, so it enables people to migrate slowly from existing OpenCLC code to C++ and benefit from incrementally add C++ features to their code base.
Great, thank you. With that, actually, Tim, this might be a good time to bring up the second poll question before we go on to our next question from the audience. So we've got three, we've done one. The second one's about what you want to use OpenCL for. So what CPU and operating systems do you currently target, or would you want to target with OpenCL if you were using it? Desktop, mobile, etc. So we'd be very interested in your view of all of those. So take a look at that. I'll do it myself.
It's like some of them are mutually exclusive.
Well, we're forcing you to pick one. That's a bit harder. Pick a favorite one. While people are clicking on that, the next question is there support or effort for TVM with OpenCL 3? Now, I don't know what TVM is. Hopefully somebody here will know what that means. So who could tackle that one?
I think the question is about the tensor virtual machine learning compiler.
Mm-hmm.
And I'm not sure I can think of an OpenCL 3 feature that would be key to TVM, at least as far as the features that are mandatory in OpenCL 3 are concerned. So if you could clarify the question, I think that would help providing a better answer.
Yeah. Anyone else like to take a stab at that while we're waiting?
Well, TVM, it is one of the key compiler chains for machine learning. So they are talking to Khronos. Their main entry point is through the Vulkan ML group right now. But as we were saying earlier, I think what we're recognizing is, rather than having 5 different working groups talking to a project like TVM or MLIR from Google, and then there are a bunch of others too, it would be better if Khronos were to organize itself so we had a single point of contact into the machine learning development community. And because different tool chains are going to find different backends useful in different use cases. So I think Khronos needs to be a little bit more coordinated on how we do that. But no, we are talking to TVM as an organization, and I agree with Kevin. There's nothing really missing. I think then they could run over, and they do. They have an OpenCL backend, but the question is, what can we add to be a more effective backend for them?
Very good. We got
Adding to that, it's not so much about OpenCL 3, but several of the extensions we have in the extension pipeline would be of interest to TVM.
Right.
We had some results there from the last poll. They just disappeared again. There we go. Again, acknowledging that you only had to pick one, and you probably wanted to pick several. So we forced people to just pick one, I guess. OpenCL on GPUs, OpenCL on Linux. Interesting.
No one using it on Mac. Excellent.
So it doesn't matter. Is that because nobody can do it on Mac, or rather nobody wants to do it on Mac? Maybe that's the problem. We got some questions about OpenCL on FPGAs, so let me ask one of those. Anonymous asks, what are the current ideas on extending OpenCL with functionality that's found in HLS? Both Xilinx and Intel have HLS. Seems that many times some features are lost by using OpenCL. So can anyone comment on status and trajectory for OpenCL on FPGAs? It seems to be a growth area in the last few years. Intel does FPGAs. Go on, Ben.
I know enough to be dangerous with FPGAs, but not enough to answer this question, I'm afraid. There's a person from Intel who I think is going to answer offline, and it'll paste it into the chat.
Okay, that's great. Thank you. Is there anyone else who wants to comment about FPGAs? I've never tried it. I've looked at it very briefly, but not actually tried it myself yet. It looks interesting. Very good. Hopefully we'll come back to that one. Let's see. There's Paul asks, and it's a question to Intel, what's the roadmap for OpenCL versus DPC++? Support on FPGA. Oh, this is another FPGA one. Is OpenCL going to remain a viable development language? Maybe start off with that. I guess, what about OpenCL versus DPC++ in general? And then is there an FPGA specific element to that?
So I can comment on the general question, and again, I'll defer to my FPGA experts for the FPGA part. I mean, in general, we're seeing a lot of uptake in SYCL and data parallel C++. Certainly both of them would be viable, but you can just see a lot more effort going into SYCL right now. We're seeing more people writing SYCL code than OpenCL code, which is fine because honestly, they both work very well together. And again, I'll punt on the FPGA specific question.
Okay, great, thank you. And then Raul's got a question regarding tooling in OpenCL. He spent years in the past using his own profiling tools. What would be the modern alternative to Nvidia, Nsight, or Intel vTune, or AMD CodeXL that works with many vendors and devices in the same platform to do profiling, advising, debugging, etc. In his own experience, vTune only supports Intel GPUs for OpenCL, not on CPUs. AMD CodeXL is abandoned and problematic. ROCm tools only for specific modern devices. And Nvidia tools are for CUDA, etc. So I guess this sort of comes back to the question earlier on, doesn't it, about profiling tools and things like that, and where Alastair was mentioning the new layers coming in the loader and Ben's tool. But are there any tools that people are aware of that are more cross-platform and across GPUs and CPUs? I think one of the answers had mentioned something like that. But then your tool's very cross-platform and cross device, isn't it?
Yeah, that's the one that I would come back to. That it doesn't have a lot of the fancy GUI that some of the others do. That's probably the biggest limitation. But if you're okay with text-based log files and some minimal visualization, it does work for all devices that I'm aware of in multiple operating systems. So.
Right, but this is an area where hopefully there's still good things are coming with some of the latest editions. It's going to make that a lot easier.
Yeah,
I think.
Sorry,
go
ahead, Alastair, or Keil.
So this is maybe also.
Go ahead, Alastair.
Sorry. This is maybe also an area where we need to do some more specification work. So this is not an OpenCL tool, but our SYCLcon implementation has built-in profiling, and it can also access a few vendor-specific hardware and performance counter details. But that is vendor-specific. There isn't a unified way to extract that information from an OpenCL implementation. There is such an extension for Vulkan, so these things are possible, although it's quite complicated because every hardware has a completely different set of counters. But maybe that's something that like an extension we could have for Respect, which would enable the ecosystem to build such a tool.
And if we go to Neil now.
I was just going to mention, I think it was maybe someone from the audience, the chat's going so fast. CL Trace is another cross-platform tool. It looks really good. It does have a good GUI, and it's cross-platform. But I agree with Alastair. If we can enable that kind of third-party ecosystem of tools to be cross-vendor, cross-platform, that would be enabling.
Yeah, I've got to give a mention to OCL Grind as well, which James Price developed when he was in my group, and he still maintains it. He's now at Google, but he still maintains OCL Grind as well, which does all sorts of useful things when you're trying to get your programs working. So check that out too. Cool, let's go back to the questions and see what's still on the table. Tom asks, for Intel, the one API ecosystem adds level 0, which replicates a lot of things already available in OpenCL, such as device discovery, kernel launch, etc. Can you speak to what was missing in OpenCL if you to use that instead of adding a new layer? So what's the motivation behind the level 0 stuff, and how is that similar or different from OpenCL?
Yeah, I assume that's aimed at me. So good question. Basically, the way I think about this is when we started working on level 0, it was a couple years ago. We weren't sure what the trajectory was going to be for OpenCL. I do think it has a much brighter future now. We're not going to stop working on on level 0, but we're continuing to support OpenCL. We were the first OpenCL 3 adopter. We continue to support new OpenCL features as extensions. So I'm expecting we'll keep working on level 0, and I do personally hope that as we discover best practices in level 0, we can roll those into the standard.
Great, thank you, Ben. And thanks for the question. How are we doing? Robert asks, great that there are plans to enhance the image 2D from buffer to other dimensions, such as 3D. We always wanted a feature like that. Are there plans for enhancing texture gather to 3D images as well? That's a nicely detailed one. Any plans for texture gather enhancing to 3D from 2D? Is that under consideration at all? Anyone brought that one up?
I think the short answer is no, but it's good to know that it's of interest to some people.
Right, so that's one we might want to follow up with Robert about then. Yeah, so Robert, yes. Thanks for bringing that up. Maybe get in touch, and it'd be good to discuss the use cases, and this is how things end up sort of on the discussion list for future extensions or revisions and so on. So brilliant.
Hey, Simon, can I ask a question?
please.
I'd like to ask Jesse, because CLon 12 is, I think, one of the most significant things that's happening in the OpenCL ecosystem. It's awesome that Microsoft are doing such a project. I'm interested. Why did you do it, and how do you expect it to be used?
Our primary interest so far has been, we have platforms in our ecosystem that don't currently have OpenCL implementations. And as I'm sure you're all aware, there are plenty of apps out there that would very much like to use OpenCL. So we wanted to make sure that all of our platforms can support all the apps out there that people want to use. And we see a layered approach as a great way to kind of bring that support without requiring all of our vendors to go build it for these additional platforms. We also saw things like our WSL environment, which is the Windows subsystem for Linux, on the horizon. And a more straightforward way of bringing OpenCL hardware acceleration into that environment was, again, to use a layered implementation instead of having vendors write targeted drivers for that environment. And then there's also just kind of the potential for a unification of support across Windows. I don't know that this is going to happen, but it's a possibility in the future that we might see kind of this being the expected way, or the potentially have behaviors that apps might want to rely on, or things like that. I don't know.
Mm-hmm. And is the performance looking good? Because we do layered Vulkan, right? And that's the first question you always get.
Yeah, I can't speak to performance too much. I haven't actually profiled it myself. What I've seen is it's acceptable. I would expect, naively based on how we built it, that if you're doing something that fits relatively well within what you can do in a compute shader in a graphics API, that performance should be good. If you're trying to do something more exotic, OpenCL has 8-bit integer support, for example, that you can't do in a HLSL compute shader. Then some of those things might get a little bit emulated and might not perform as well.
Right. Interesting. Yeah, we found the same thing. I mean, there's nothing, once you stay within the capability of the underlying API there, the performance is awesome. That's what we found on other APIs as we do layering. But I think the layering is going to be one of the key things going forward, because it hasn't come up. I'm surprised. Perhaps it's because there's no one using Mac. But no, deprecation of OpenCL Mac is a big issue, and a layer over metal, is the way to solve that. And if we're not providing enough coverage to devices through native drivers, then layering can help in lots of different ways. The trick is going to be to make it happen. So that's the interesting discussion we have going forward.
That was going to be literally my next question, was about if anybody's working on a OpenCL over metal layer. That would be, or OpenCL over Vulkan over metal. I don't care.
It's being discussed. I'm not aware of any projects that are like off and running, but I think we need to find a way to make that happen somehow. We don't have.
I'd imagine there's got to be a lot of software developers that are being left in the lurch by this OpenCL deprecation. So, yeah. And porting a bunch of stuff to metal, it's doable, but if we can avoid it,
yeah,
it's
an opportunity for real value add if we can figure that out. And as I say, we have the exemplar in Vulkan. Vulkan has exactly the same problem, and we do have multiple layered Vulkan over metal, and it's being used by production apps. It's not a theoretical research project. It's a real tool.
So we've got a last poll question. So Tim, I don't know if you could fire up the third of the poll questions, which is going to be about competition. What's the main competition for OpenCL? And this one is multiple choice, so you can click more than one. So which do you think are the main competition for OpenCL? If you're not going to use OpenCL, you're going to use something else instead. What is that going to be? So I'm going to click this myself. Let's see, what do I think I'm going to do from a high performance computing point of view. I'm going to do that one. No, all right, I clicked more than one. While you're all doing that, and before I come to the last few questions, a general one that follows on from what we were just talking about. What are the application areas that are driving OpenCL use? So obviously Paul's nicely representing the sort of content creator side, and obviously it sounds like there's a lot of that really wants to use OpenCL. But what have you all come across as the main uses of OpenCL? And it could be in the mobile space or the desktop space or anything really. And is there anything new that's sort of driving that?
I think in the mobile space, there are two that we're seeing that are a really strong pull, and that's machine learning and computational photography.
Mm-hmm.
Yeah, and in the desktop space, we do see it's the creative applications like Paul's, plus medical. There's quite a lot of use in medical as well on desktop.
Yeah, Alastair?
Vision processing in general, in addition to the ones everyone already said.
Cool. And then Jesse, I don't know, from what were the things that were sort of motivating your work? Were there certain application areas that were creating the most pull-through?
Yeah, it seems to be image processing for the most part. One of the big ones was Adobe Photoshop. Has a lot of OpenCL code.
Great, thank you. So going back to the Q&A, when we have the results, there you go. So I guess we're not surprised CUDA's the main competition. Given that OpenCL is quite low level. But what else? We've got SYCL. That's good. Standard C++. Yeah, that seems to be a trend towards that one as well. A little bit of OpenMP, a little bit of Vulkan. Very interesting.
And maybe just a comment on that, though, and it kind of comes back to my original observation about data parallel C++, is SYCL and standard C++, and even some higher level models like OpenMP, maybe OpenACC, those don't need to be competition. All of those need some sort of a driver level to run through. So there's lots of options in this space, but OpenCL is one of those, and it doesn't need to be a competition.
Yeah. Great, thank you, Ben. Awesome stuff. Alex says OpenCL is on Mars, helping to fly the helicopter. And I didn't know that. I
didn't know that. Is that true?
I hope that's true. We need a sticker. I want that sticker on my laptop like tomorrow. That would be awesome. Cool. Oh, there's a question about real time. That's an interesting one from Miguel. Is there any consensus or general direction in using OpenCL for real-time applications? Is this something that wants to be pursued or left to the implementation? Real-time OpenCL. Anyone working on that? Alastair.
That is an interesting question. I'm limited in what I can say because it's quite early days, but one of our target markets is automotive, where obviously you're generally running in a real-time OS. So we are looking at real-time OSs with running OpenCL. Thus far, we've not really been thinking about any changes to the OpenCL interface or specification beyond essentially embedded profile. So that's not really a very interesting answer, but it's
no, but automotive is quite an interesting area, right? So I guess that brings up, I guess, safety as well as real time, things like that, which is a whole other ballgame.
Yeah, we have had discussions in the past whether we need to do a safety critical profile. We haven't done it yet, but it is an interesting discussion. One of the adopters that they haven't shipped anything yet, but they have become an adopter is QNX. And they're very much into real time and safety critical stuff. So it'll be interesting to get their input.
Right, and Miguel, if there's a use case behind your question for real time, do get in touch. It'd be interesting to know more about what the potential need might be there. Excellent. I think we've addressed most of the others as much as we can in terms of I think there were some follow-ons on the FPGA side, on the OpenCL versus DPC++. And then there was I think the other one we got there as well. Oh, and there's a follow-on about the real-time. At Grass Valley, we use OpenCL for real-time video processing up to UHD. Oh, wow. change of frame size and all right. Very cool.
Yeah, we're doing the same thing at Boris FX with various products. I guess my definition of real time is different from the previous commenters because we're not talking real time OS or anything like that, but we are able to do these things in real time.
Excellent. Well, we're in our last 3 minutes already. That hour has gone so quick. If you haven't had the chance to ask your question yet and you want to get it in there, type fast. Probably got time for one last question. We'll see if anyone gets in there before we finish. We will have a live panel again tomorrow. Be on SYCL tomorrow. So OpenCL today, SYCL tomorrow, same time. So do come and join us. How many attendees are there? Well, I think Tim said we've had over 500 people sign up to the overall conference, and we've had 85, 90 on this live panel. So that's quite a few, and all of the videos of the talks and the slides and things are all available now on the website. So do go and check those out. And then Eric, this might be the last question now. Eric asks, why would a safe OpenCL profile need to be different from an embedded profile?
So safety critical profile is slightly different. I mean, obviously there's a lot of overlap between embedded and safety critical. Most safety critical apps are also embedded, but safety critical goes beyond just saying what do DSPs need, or what kind of DMA operations do we want. It goes into things like easy system certification, reducing costs of system certifying to standards like ISO 26262. You need to be NISRA compliant headers. You want to have deterministic error handling. You want to get rid of anything that's non-deterministic in memory management. So you end up stripping out quite a lot to be safety critical. It's beyond just having OpenCL running on your DSP.
So there's a lot to it.
Yeah, and again, I mean, there's a Vulkan SC working group working very hard on a Vulkan safety critical version. I think OpenCL is already smaller, so we're actually in a kind of a better space, as a starting point at least. So, but if people are interested, again, as always, please let us know.
And there's also the advisory group, right? I mean, is it worth doing a quick plug for that, Neil? If people would like to get involved.
Yes, very quick plug. If you go to the Khronos website, it's called the Khronos Safety Critical Advisory Forum, which is open to anyone. They're not designing safety critical APIs, but they're designing the guidelines and gathering the requirements for what safety critical APIs need to do. Because when we started out, we discovered that no one really knew. And so we created the forum to, again, just like we might do with the machine learning community, just a general outreach into that whole safety critical community to understand what they really want out of our APIs.
And then there's also an advisory group for OpenCL itself, isn't there? People would like to get involved in the standard.
Yes, the advisory panel is something we would welcome anyone. If you've come to IWOCL, you self-qualify. So let us know if you'd like to be on the advisory panel. It's if you're willing to sign an NDA and go under the Khronos IP framework, we can share draft specifications with the advisory panel, and even take design ideas because we're covered by the IP framework. And we're looking to really build up our interaction with the advisory panel and build out the membership. So please do strongly consider coming onto the panel. We'd love to talk to you there.
So you can get involved. Nothing better than getting directly involved. If people want to do that, Neil, how do they do that? Do they get in contact with you? Do they go to the Khronos website? What's the best way to do that?
There's some links. Actually, if you go to my presentation, there are links in there and some bit more background. So yeah, that will be a good starting point.
Fabulous. Well, with that, we are at the top of the hour. That went really fast. Thank you so much, everyone, for joining us. My huge thanks to all of you on the panel. Thank you for being here and fielding all the questions. Thank you to all the attendees. There's loads of great content on the IWOCL and SYCLcon website now, so do go and check out all of the talks. And do come and join us again tomorrow. Think up all your interesting SYCL questions and pose them to a SYCL panel tomorrow. So thanks again to the panel, and thank you all for attending. Take care, everyone. Thank you.
Thank you, Simon.
Thank you.